So if I start from here again, what is IUPAC nomenclature? It's a method of naming the organic compounds. Why such a method was needed? Because organic compounds were so many and increasing every day. So they thought about, so they thought about a method, a technique, a systematic procedure. They thought about a systematic procedure to name organic compounds. What is the fundamental idea here? All organic compounds are assumed to be derivatives of alkanes. So let me know if have you copied this screen?
Yes, I have derivative. Yep.
All organic compounds are assumed to be derivative of alkenes. It means we assume that alkenes are their forefathers. Now, how we translate it, the families of organic compounds are all named in the name of alkenes. Alcohol is the conventional name. Alcohol is the conventional name, but we call them, we convert their name and we call them alcohols are named as alkanols. This is a method of naming under IUPAC. You have to copy this screen.
Okay.
I'm just coming, copy this screen. Alcohols are called alkanols in this system. Aldehydes are called alkanales. Ketones are called alkanones. Carboxylic acids are alkanoic acids. Alkyl halides are called halogenoalkanes. Esters are called alkyl alkanoids. Let me know if you have copied it.
Yeah, just in the last three.
Now, have you copied it?
Just on the last one, the esters. 1 second. Is it alkanoates, right? Correct. So esters turn into alkyl alkanoates, correct? No.
Yes.
Okay,
Esters
done.
are alkyl alkanoids.
Okay, copied.
Paraffins are alkanes, olefins, alkenes, ethers, alkyl, alloxyalkanes, amines. IUP is not used. Amides are for that are not used. So these are some common names for them. And whenever you talk about this system, you name the positions, number the positions, and in order to manage them, we actually connect them with alkanes. You have
Okay.
to, sorry, you have copied, what you have copied, huh? You have copied this screen. Now you have to copy this screen.
Yeah, I copied them.
Now, we are putting some important terminologies in organic chemistry. Organic chemistry is too formal and it's too much spread. So we need a good background to start it. And for the topic, you can say, and once you have a good background and you know the basic things in a good way and you have good notes, then you can tackle this chemistry. It's mainly a memory chemistry. Numericals are very limited. It's mainly equations and other things. So terminologies associated with organic reactions. Now you have to give this heading.
Okay. Yeah, copied it.
There are some important terminologies. Functional group, we already have discussed. Homolytic, heterolytic fission, free radical, initiation, propagation, termination, nucleophile, electrophile, addition, substitution. It's a whole different world. Actually, organic chemistry being so big have evolved as a separate subject, own terminologies, own paradigm, own horizon. So that is why it should be started in a bit extended way. Gradually, obviously, you have to do only alkenes, one topic in unit 1 and few topics in unit number 2. You have to copy now this screen.
Yep.
Let me know once you have copied it.
Yeah, I've copied it.
Homolytic and heterolytic fission. When a bond is broken, it is called fission in our organic chemistry. Normally, a bond cleavage is a simple term. So when a bond is broken, it is called fission in case of organic chemistry. Now, whenever you are talking about a fission, there are two options. Look at carefully. When you make a bond between two atoms, like X is a bond with Y, and these are the two electrons. These are the two electrons which are between the bond, between the bonded electrons. These are the bonded atoms. These are the bonded atoms. Now, make a concept. If you break the bond, there are two possible ways. You break the bond and you return the electrons to their corresponding elements. X got his electron and Y got his electron. This is called homolytic fission. Another way of breaking the bond that both the electrons are taken by X and Y has deprived from its electron also. In this way, a positive and a negative ion is formed. This is called heterolytic fission. So let's revise. Bond can be broken in two ways. If you justly separate the electrons, if you give each electron, if you give each atom one electron, it is called homolytic fission. If you divide electrons, one atom took both the electrons and run away, that will be a negative ion, and the other atom has been deprived of his electron, it is called heterolytic fission. Look at carefully, the first one. Look at carefully. A and B are separated. They have taken their electrons. Now they are free to go. They are called free radicals. This is called homolytic fission. You have to copy this. Have you given this heading? Sorry. Have you given number 1 heading?
No, not yet.
Okay, first give the heading.
Yeah, done with the heading.
Now you have to copy this screen.
What's this word? Fission is cleavage? Is that the word?
Sorry, can you repeat? The word
It
cleavage.
says cleavage.
Cleavage
Okay.
cleavage is a word for fission, bond breaking. The word cleavage means bond breaking.
Okay.
Now look at this diagram, this thing which I had explained. Now, if you break the bond in such a way that one atom run away with both the electron and other is poorly deprived. This is a case of homolytic fission. I have shown an example in the bottom, second line. It's a polar bond. So when I break it, look, there is a plus sign on carbon and there is a minus sign on chlorine. This is a case of heterolytic fission. Heterolytic fission means the bond breaks unequally. You have to now copy this.
Okay. Yeah, done.
Now, there are two types of bond. When we were discussing bonding, we discussed this topic in detail. But as mentioned earlier, we couldn't do questions. And that is something which is lacking badly because chemistry or any science A-level subjects comes when you do the past paper questions. There are two types of bonds. One is called polar, in which one is plus and one is minus. Second is a non-polar bond, heterolytic fission and hemolytic. So it means when you have a polar bond undergoes heterolytic fission and a non-polar bond undergoes homolytic fission. This is a rule to remember. You have to copy this. Hmm.
Yeah, copied it.
Now give a new heading, free radical. Free radical, what are free radicals? When a bond is broken, homolytically, you will get two neutral atoms. Very interesting concept in chemistry. Neutral atom means no excess electron, no deficient electron. But in organic, we have a special name. So when you break a bond in such a way that both atoms take away their electron and now both are neutral, they are called they are called free radicals. What is the meaning of UV? Do you know this? Do we UV? We
Yeah,
use in
ultraviolet, right?
yes, very good.
Yeah.
Ultraviolet radiation. You have to now copy this.
Yeah, copied it. What does it mean by a free radical, though?
Sorry,
What does it mean by a free radical?
free radical is a neutral atom. Free radical is
Okay.
a neutral atom. I give you a simple example. For example, I say I have sodium. It has 11 electron and 11 proton. The charge would be 0. In normal chemistry, we call it neutral atom. But in a reaction, when it is produced, it is called free radical. When a bond is broken and every atom take its electron and go back home, they are called free radicals.
Okay.
Nucleophile and electrophile. Now give this heading.
Yeah, done.
Nucleophile. Nucleophile is a negative ion neutral molecules with lone pair. Now you should understand one thing. Many concepts you are looking here are nothing new. They're just like new names. What do you call negative ion? You must remember cation, anion. But
Yeah.
here we call it negative ion. We give it a new name, nucleophile. Neutral molecules with a lone pair are also called nucleophile. As I mentioned, organic chemistry is too big that it evolved as a separate branch. That is why they had to introduce a good number of terms. You have to copy this. For example, nucleophile CN minus, CH2, OH minus, Cl minus, they all are called nucleophile. What is a nucleophile? It's a lone pair donor. If a particle has a lone pair of electrons and it can donate it to someone, it is called a nucleophile. You can see a very technical reaction underway. Remember, this curved arrow in chemistry shows, this curved arrow in chemistry shows electron transfer. Nucleophile is an electron pair donor. It can attack a positive section and it can attach it there itself there. So now you have to copy this.
Okay, 1 second. Just the last part.
You are copying it?
Yeah, yeah. No, no, not this one. The last part of yeah, right.
Have you copied it?
Yep, copied.
So we keep it up to here and we will inshallah continue in our next class. Please try to arrange topical books. If you get them, let me know in the week so we can start the follow-up of our past paper questions.
Sure.
Thank you.
Okay. Welcome.